We have looked at conditional statements, and we have looked at the converses of conditional statements. We are going to include a couple more ways that we can change the conditional statement. So a conditional statement if P, then Q. We'll have a converse. What is the converse of the conditional? I heard it up there. You basically take your hypothesis and conclusion, which are P and Q, and switch them around. So if Q, then P. Okay, now what the conditional says is whenever P is true, absolutely positively without exception, Q must be true. That has to be the case in order for it to be true, a true conditional. So for example, we've come up with if it is raining, then there are clouds,
Yes.
which is a true conditional.
Why is it raining out of clouds? Yeah. Why is it raining when it's sunny out? You know that one cloud.
The converse of this conditional says, if there are clouds, then it is raining, which is a not true conditional. So you can always classify these conditionals as true or false.
Do you have to raise it?
No. This one's true, this one's false. Would it be wrong to write it down though? No. If you want it in your notes, you can include it. It's all a part of the lecture.
True and false.
Now, what we are going to do is we're going to talk about the inverse of a conditional, which is if not the hypothesis, then not the conclusion. And the contrapositive of the conditional. The contrapositive is actually the converse of the inverse, which means you take not Q and not P and switch their places.
So not human.
Yes. So here, P is the hypothesis. And Q is the conclusion. Whenever P is true, without exception, Q must be true in order for these statements to be true.
That applies to the inverse of
Yes. Now with inverse and contrapositive, notice this piece right here is the hypothesis. And this piece right here is the conclusion. Still, in order for them to be true, when the hypothesis is true, Without exception, the conclusion must be true. So let's go ahead and write our if it is raining, then there are clouds into the if not P, then not Q form. Now notice P is it is raining, right? That's P. There are clouds is Q. So how do we go not P? If it is not raining, yes. So we are going to have if it's not raining, then there are no clouds. And the question would be, is this a true or false statement? So whenever it's not raining, without exception, there can be no clouds. That's a false statement, isn't it? So this is a false statement. Now the contrapositive, and which is what Dustin is saying, and Branson and Nick, you need to be paying attention. That means not visiting. Okay. So if not Q, then, since there are clouds is Q, then not P. So not it is raining. How would we write the contrapositive?
There are no clouds, it is not raining.
There you go. So if there are no clouds, then it is not raining.
So the contrapositive is always raining.
It ends up that the contrapositive will be right whenever the original is right.
And the inverse is always wrong.
And the inverse will be whatever the converse is. So if the converse is wrong, the inverse will be wrong. When two things are always the same, whether one is true, the other one's true, whether one is wrong, the other one's wrong, we refer to that as them being logically equivalent. So the original and the contrapositive are always logically equivalent. Which really means if one is true, the other one has to be true. Or vice versa. If the one is false, the other one has to be false. We are going to use this to help us do what we call an indirect proof. Because if I can prove the contrapositive is true, that means that the original conditional is true. So tomorrow's assignment will be doing an indirect proof using this idea. For today, what we're doing is just experimenting with the whole idea of changing these statements from one to the other and seeing if they are true or false. So let's practice on one or more, and we're also going to look at what this looks like in a Venn diagram. It is. A Venn diagram is one with circles. Now, our original conditional if P then Q means that whenever P is true, without exception, Q must be true. So in a Venn diagram form, what that means is whenever you're inside P, you must be inside Q, without exception. Whenever you're inside P, you must be inside Q means P is which of these circles?
So P is the small one.
P has to be the small one in the middle.
And then it's always going to be.
And Q then has to be the one that is outside that. Because whenever you're in P, you have to be in Q. Now, playing with this a little bit then. I'm on the top of page 209, and it says, all runners are athletes.
No.
So if you could gather your attention, please. If all runners are athletes, we're going to write this as an if-then statement so we can figure out what is P and what is Q.
You're a runner, then you're an athlete.
So if-then, if you are a runner,
That's formal.
then you are an athlete. I don't think you'd be called really a runner.
Well, you could be in your car and you're a runner, running.
So let's draw a Venn diagram that represents this statement then. Using this idea, our Venn diagram, what will be on the inside?
P or Q, Q, F.
The P part, which is the hypothesis. What's the hypothesis here?
Runner.
You are a runner. And athlete then is the outside. All right. Now they give us some statements. They say Leroy is a runner.
Wouldn't it be athlete and a runner?
No, the reason why not is because if a point is in P, it absolutely must be in Q in order for it to be true.
That's good, that's good.
Runner, meaning if a person is in the runner, they absolutely have to be in the athlete. Now the question would be, are there other
Yes.
things in athlete group?
Yes.
Yes, there are. We have
Swimmers, jumpers,
swimmers,
shooters, killers.
we have football players, right? Are there some football players that are swimmers?
Yeah, I am.
Okay. Are there some football players that are swimmers and runners?
Yeah.
Okay, that'd be right there then, in the middle of all of them, right?
That's how they make the Olympic sign thing.
Right. So then, this right here would be more of this Venn diagram. But all we're drawing when we're drawing the if-then statement is the one piece. If you're a runner, then you're an athlete. But there are more athletes than just runners.
Yeah.
Does that help it make sense a little bit?
Yes.
Okay, so our statement number one is that Leroy is an athlete. No, that Leroy is a runner. Thank you. Now, what is our conclusion using the Venn diagram? If Leroy is a runner, he's an athlete. So we write, all right, statement number two now. They say Lucia is not an athlete. I'm on the top of page 209. And I chose a random letter to represent Lucia because I chose an L for Leroy already. Lucia is not an athlete. I'm just reading what they gave me. We're working with it. But she's not an athlete. So where would Lucia be? Where would Lucia be in this Venn diagram then? Right out here, right? Because she's not an athlete. So what is our conclusion since she is out here? According to this statement, she is not a runner. Statement number 3 now. Linda is an athlete.
No, it said question.
No, she doesn't say she's a runner.
Exactly. So because there's a question mark, Linda is an athlete. She could either be here or here.
It says she might be a runner, but she might not.
Exactly. Whenever there's that word might, then you have no conclusion. So here we have no conclusion.
Mary is not a runner. Might be.
Now, our next one, Larry, is not a runner. He could be an athlete. So here we have Larry. He's either an athlete or he's not an athlete. Because there is the word could be or might be, there is a no conclusion.
And then we got Larry. Larry. And he is what runs.
Okay. Now, turn the page. What we are going to do on page 211 is we are going to write these statements and then decide if they are true or false. So number 5, what we have is if I live in Los Angeles, then I live in California.
Yep.
But there could be a different time.
Mark got a
One of them left LA.
Mark. Mark.
That's true.
So we could draw a Venn diagram. They don't tell us to, but we could. Here is LA, and this is California. Now, the original conditional is true. Now we're going to write the contrapositive, the converse, and the inverse. Okay, help me come up with these statements, and then we'll say true or false, and we'll end with this last piece. Okay, so this next, what is the contrapositive? Okay, I need your help. Exactly. Contrapositive is if not Q, then not P.